So, as we discussed in the last lecture, psycholinguistics is the study of the relationship between psychology and language. And we contrast psycholinguistics with linguistics, which is just concerned with studying language itself, not necessarily how language impacts our psychology and how we use it as humans. There are four sort of main concerns in psycholinguistics. How we comprehend language, how is language represented in the mind, how we produce language, and how we learn language. What we're going to do today is just take a very brief look at two aspects of language related to comprehension. Lexical access, so how we pull words out of our mental dictionary, out of the lexicon, and parsing, how we understand sentences. So it's just going to be a whirlwind tour of two sort of key ideas in psycholinguistics. There's literally a whole course on this here at Acadia. This is a massive field, so this lecture today will necessarily just be sort of a brief overview. So we'll start by talking about, how do we understand words? So we all have this mental dictionary in our brains called the lexicon. And when you see a word like cat, right, you get a bunch of stuff. There's a bunch of things that come along with the recognition of that word. So word form, right, how we write cat, its grammatical class, so how you would use it in a sentence, its frequency, how common that word is. Cat, fairly frequent word compared to something like, leopard or cougar. We get its meaning, of course, and we also have access to words that are related to cat. So we know from priming studies, when you see cat, you're a bit faster to then react to, for instance, dog or pet. So we can look at, the speed at which we react to words, the speed at which we say that words are words, and this tells us something about how the lexicon is organized, how we have access to all of this wonderful information when we see words or hear words. And we do that using what's called the lexical decision task. Now, we've looked at lexical decision tasks previously in this course. I talked about them in the lecture on thought. And that's because concepts are sort of inherently tied to language. Right? As we discussed in the last lecture, we think using language. A lot of what we know is sort of embedded in linguistic terms. And so that's why, we can study the structure of the mind, how concepts are organized, using lexical decision tasks, basically, by examining how the lexicon is organized. So these two things are highly related. And so, just to remind you, the idea here is that you show participants a grouping of letters, and they indicate as fast as they can whether what they're seeing is a word, something they recognize as a word, or not. And in that second case, when it's not a word, there are two possibilities. So it could be what's called a legal non-word. So something like glurp is a legal non-word. And so it's legal because the letters are combined in a grammatical way. Glurp could theoretically be a word if we assign some meaning to it, but right now it's meaningless, and so it's a legal non-word. But lexical decision tasks will also often have illegal non-words. So this would be like a word, for instance, without any vowels. All words in English need, at least one vowel, and so this is an example of an illegal non-word. And just by examining the speed at which participants respond to words, legal non-words, and illegal non-words, it tells us something about how the lexicon is organized. So if you recall, the way this works is that you're simply asked to respond as quickly as you can. Is this a word or not? And so a word appears on the screen, and you would press a button very quickly to indicate that terp is not a word. It looks like a word, but it's not a word. So this would be a legal non-word. EGOT, again, looks like a word, but it's not a word. Tree is a word. Trim is not a word. So this is actually an illegal non-word, right? There's no vowel in there. Toll is, of course, a word. And so we can just look at the reaction time, the response times. And, you know, if this was an experiment in the lab, you would do this many, many times over and over and over again with many different words. And so what we're interested in is how long, for instance, it took you to respond to the legal non-words versus the illegal non-words. And so this is, you know, quite a classic finding, which is that illegal non-words, participants are very quick to say that that's not a word. Whereas legal non-words, it takes participants a long time to say that legal non-words are actually not words. So what's happening there? Well, one idea, one possibility is that, you know, to access the lexicon, to look into the lexicon, to look for words, to look for ideas, you have to, as a start, meet the rules of grammar, right? So if you're a word and you don't contain a vowel, then your brain automatically knows no point in looking for that word. That's not a word. You know, you hit that not word button very quickly. Terp, on the other hand, it's not a word, but it looks like a word, right? It obeys the rules of grammar. It has consonants and vowels in the right places, and it actually looks like kind of like trip, which is a word, right? And so it takes you a long time to say that terp is not a word because you actually have to search through your entire lexicon, through your mental dictionary, and go through a number of different cases to rule out the possibility that, you know, actually terp is not a word. There's no meaning attached to terp. We can look at tree versus toll. This is an interesting example, right? So these are two words. And if we were to do this experiment in the lab, we would probably see that people will respond faster to tree than to toll. And why is that? Well, that's probably because tree is just a much more common word than toll. And that tells us something about how the lexicon is organized, how concepts, how thoughts are organized in the mind, right? It tells us that, you know, words that we commonly access, that we frequently access, are sort of closer to the front door of this mental library. And so word frequency is something that is computed by psycholinguists. So there are tables where you can look up, you know, the frequency of particular words. Home versus hike, for instance. So home, very frequent word. If you encounter 1,000,000 words in a piece of text, 547 of those are likely to be home. Hike, on the other hand, if you encounter 1,000,000 words in a piece of text, you know, probably only 3 or 4 of those words will be hike. And so we would expect that in a lexical decision task, people are a bit faster to say that home is a word than they are to say that hike is a word. And again, that tells us something about how information is organized in the lexicon, how thoughts are organized in the mind. We can also see word frequency effects by looking at gaze duration. So how long you look at words during reading, right? So if you were to read the sentence, the slow waltz captured their attention, and we were tracking your eye movements, we would see that you actually spent a lot of time looking at waltz. because that's a low frequency word. And so the idea here is that you're looking at it for longer, you're paying attention to it for longer because it's taking you longer to find that word in your brain, to access the meaning of that word. On the other hand, if you read the slow music capture their attention, right, we'd see that you don't spend as much time on music as you do on waltz because music is a much more frequent word. And so we can see that in this bar plot here from this 1986 study by Rayner and Duffy. When you're reading, you tend to fixate on low frequency words for a longer period of time than you do on high frequency words. You give those low frequency words more of your attention because it takes you longer to find those words in your mental dictionary. So when we understand words, we often rely on context, prior knowledge, right? Prior knowledge, this idea has come up a lot in this course. Perception is a combination of bottom-up information, sensory signals, and top-down information, prior knowledge. And language is no different. So if you hear the sentence, I scream, you scream, we all scream for ice cream, acoustically speaking, I scream and ice cream are identical. If I was to show you the acoustic trace for ice cream versus ice cream, they would look the exact same. What you're doing here is you're using some context, your prior knowledge of how words are grouped in sentences and your knowledge of grammar, to disambiguate what would otherwise be an ambiguous acoustical signal. Now this also comes up when you're reading. So there's something known as lexical ambiguity, and this is encountered when you read words, or hear words I should say as well, that have multiple meanings. And so these types of words are known as homophones. So we've talked about one homophone in this course is the word bank, right? When you hear the word bank, does that refer to the place where you keep your money, or a riverbank? And so context can help us solve this problem, right? If you hear the sentence, the man is going to deposit his money in the bank, you know exactly what that means. What doesn't come to mind there is, the man like digging a hole in the side of a river and like burying his money in the ground, right? You understand, based on the context of the sentence, what bank means. But what psycholinguists have been really interested in is the speed at which you use context to disambiguate ambiguous words. To flip that around, psycholinguists have been very interested in the idea that, when you initially hear an ambiguous word like bank, do you automatically access both interpretations of that word and then use context to disambiguate the ambiguity? Or are you using context online to restrict access to the meaning that makes sense? And this might sound like a very weird sort of thing to be worried about. Like, why did psychologists, who cares? Like, we end up with the right answer. But it says something about how the mind is structured. It says something about whether the mind is very interactive. So in the interactive approach, context acts immediately to restrict access, to make it so that, when you see an ambiguous word, you immediately use context to only withdraw the meaning that makes sense from the lexicon, versus a more automatic, what a psycholinguist would call modular view, which is that there are some processes that just happen and there's nothing you can do about them. And so when you see a word with multiple meanings, you automatically access both meanings, and then after the fact, you use context to sort of figure out what's going on. This seems like a very, again, a very nuanced problem, and you might be thinking, as I just said, who cares? But it is an important problem, and it does say something about how the mind works, whether the mind is very interactive or whether things sort of just happen, and top-down knowledge is sort of applied after the fact. And if you take psycholinguistics, we'll spend like a whole class sort of diving into this problem and why it's super important and why it says something about how the mind is structured. But for the purposes of this brief introduction, I'm just going to give you the answer. So, when you see an ambiguous word, what happens? Does your brain access both meanings and then you use context to disambiguate the situation? Or are you using top-down knowledge, sort of on the fly to limit your access to the meaning that makes sense given the situation? So imagine you encountered this sentence. Rumor had it that for years the government building had been plagued with problems. The man was not surprised when he found several spiders, roaches, and other bugs in the corner of his room. Okay, so bugs is a homophone. It can mean two things. It can mean insects. It can also mean spy equipment. Now, in this context, it's pretty clear what it means, right? The man found several spiders, roaches, and other bugs in the corner of his room. So the context helps us disambiguate what this word means. But again, psycholinguists are interested in, when you see the word bugs, despite the context, does this actually lead to access of both meanings? And so a study was run, a very famous study was run in the 1970s to investigate this. The study was run by Colin Swinney. It involved what's called cross-modal priming. So priming across two modalities. Participants were hearing something and reading something, doing a lexical decision task, at the same time as they were hearing a sentence. It's a very complex study. And so the way this works is that participants listen to sentences with some sort of ambiguity, with a homophone, so a word that has multiple meanings. And that homophone acted as a prime. They then had to make a lexical decision about a visually displayed word, so the target word. So imagine you're a participant in this study. You would hear, so auditorily, the sentence I just read. So rumor had it that for years, the government building had been plagued with problems. The man was not surprised when he found several spiders, roaches, and other bugs. And as soon as you hear that word bugs, you have to make a visual lexical decision task. So either ant, spy, or so will appear on the screen, and you have to press a button to say whether these words are words or not. And the sentence is still being played, so the sentence is still sort of finishing as you're doing this task. And so the idea here, right, is that when you hear bugs, if both meanings are accessed sort of automatically by your brain, then we should see that bugs actually facilitates or primes your response to ant and to spy. So both meanings are being accessed when you hear bugs. Despite the context, despite what's happened before, if both meanings are being accessed, the insect meaning and the spy equipment meaning, then hearing that word should make you respond a little bit faster in this lexical decision task to ant and to spy. On the other hand, if the brain is really interactive, if top-down processes can sort of on the fly restrict lexical access, then we should expect that the context of the sentence you just heard limits your understanding of bugs to the appropriate understanding. So in this case, an insect. And so we only see priming for the word ant. And so what do we see? And sort of, I think, the gut reaction is that, of course, the context of the sentence is going to limit, our interpretation of this word to ant, but that's actually not what we see, which is really interesting. What Swinney showed in the study was that words that were related to bugs, in both the appropriate context, so ant in this case, and in the inappropriate context, spy, were both primed. So there was both this sort of facilitation in how quickly people said these words or words in this lexical decision task. So what does that mean? It means that when you encounter a word with multiple meanings, all of the meanings are initially accessed by your brain. That's an automatic process. It doesn't seem like we can sort of get around that in any way, regardless of the context of, the sentence that the word is in. And then after the fact, we use sentence context to disambiguate the ambiguity. And Swinney nicely showed this actually in his study, because in this case, you hear that word bugs and you immediately have to do this lexical decision task, decide whether ant is a word, spy is a word, or so is a word. And you see that, bugs primes both ant and spy. But if you wait just 200 milliseconds after participants have heard this word bug, and then you give them a lexical decision task, if you wait just that short amount of time, the priming effect for spy goes away. So in just that short amount of time, you're able to use sentence context to go back and decide the only meaning of bugs that makes sense here is the insect meaning. And so this leads to priming for the appropriate word in this case, and no priming for the word that is inappropriate based on the context of the sentence. So the answer here, the takeaway, is that when you initially encounter a word that's multiple meanings, your brain automatically accesses all possible meanings of that word. But very quickly, within 200 milliseconds, you draw on context, so you use top-down knowledge to disambiguate the ambiguity. And again, sort of just to repeat myself, this might seem like a very nuanced, sort of weird question to be concerned with, but it does say something about how the mind is structured and how thoughts are sort of automatically accessed, and how sort of top-down information interacts with bottom-up information. So we've looked at ambiguity in the context of words, homophones. Let's look at some ambiguity in the context of sentences. So imagine you saw this sentence, "One morning I shot an elephant in my pajamas." Now this is an ambiguous sentence. Why is it ambiguous? It's ambiguous because we don't know whether the person doing the shooting is in their pajamas or whether the elephant is in the shooter's pajamas, right? And so we can complete this with, "How he got into my pajamas, I'll never know." This is a classic sort of Groucho Marx joke. Groucho Marx was an American comedian, I believe in the 1930s. And so how we understand sentences is known as parsing. And parsing is basically the process by which we sort of unconsciously, when we're reading and listening to sentences as well, we group words together into meaningful units or phrases. And so if you read this clause here, after the musician played the piano, everything seems fine, okay? And we see the following: after the musician played the piano, she left the stage. That's all fine. We can read that without any problems. But once in a while, when we're reading a sentence, we encounter a problem and we have to reevaluate how we've grouped words together, how we've parsed the sentence. So imagine, you saw after the musician played the piano, was wheeled off the stage. So after the musician played the piano was wheeled off the stage. That's a very awkward sentence, right? You get to the word piano, and then you see was, and you realize that how you've grouped the words together to understand the sentence doesn't make any sense. And you have to go back and sort of reevaluate how you've parsed, how you've grouped words together to understand the sentence. So in this case, right, you'd go back and you'd say, okay, so there needs to be a comma after played. After the musician played, comma, the piano was wheeled off the stage. And so sentences like this that have some sort of structural ambiguity that forces us to reevaluate them are known as garden path sentences. And parsing, how we group words together to understand sentences, is studied using using these garden path sentences. And garden path sentences are sentences that are grammatically correct. They will just lead to a misinterpretation on the first reading. So what psycholinguists are interested in is how we solve this problem, how we solve this misinterpretation. And just like when we were talking about how we understand words with multiple meanings, and the debate sort of centered on, how early does context act? How early does top-down information act to restrict our understanding of words? Same sort of debate is happening with parsing. So, how early does context act to shape how we parse sentences? Now, why are these called garden path sentences? To be led down the garden path means to be tricked or to be deceived in some way. And so psycholinguists look at how we parse sentences that lead us down the garden path and whether context can help us avoid that. So help us parse the sentence correctly on the first sort of go around. Two famous sort of garden path sentences. The horse raced past the barn fell. It sounds almost nonsensical. Again, you're grouping the words together. So you group the and horse raced past the barn, and then you get to fell and you realize that you've been led down the garden path. You've been tricked. And so you have to go back and rethink the sentence. And so it makes more sense if you think about it as the horse, comma, that was raced past the barn, comma, fell. Same idea with the man returned to his house was happy. Again, you get to house and everything's fine, and then you hit was happy and you realize that you've been tricked, you've been led down the garden path. You have to reevaluate. So in this case, just like the sentence above, you can think about this as the man, comma, who was returned to his house, comma, was happy. And so again, the idea here is, in both of these cases, we've been tricked, we've been led down the garden path. Can context help us or prevent us from being tricked? That's sort of at the heart of the debate between psycholinguists when it comes to parsing. And so models of how we parse, of how we group words together when we read sentences, come in two flavors. One flavor suggests that context can't initially help us. And this is known as the garden path model of parsing. And it basically proposes that we will always be garden pathed, we will always be tricked when we encounter a sentence like the horse raced past the barn fell. And the garden path model simply proposes that parsing is governed by a number of rules that are simply based on the rules of syntax. And we're simply following those rules. And so if we're following those rules, it makes sense to just, on the first read of the horse raced past the barn fell, to group together the horse raced past the barn. And then you hit fell, you realize you've been led down the garden path, and you have to reparse the sentence. And so you read it again and you think, okay, the horse, comma, raced past the barn, comma, fell. Garden path models propose that parsing, how we group words together when we read sentences, is governed by a rule known as late closure. And so the idea here is basically that, the simplest interpretation is probably the most correct. So new words are added to the current phrase if they're syntactically plausible. Right? So if you're reading this sentence, after the musician played, the piano was wheeled off the stage. Right? We've read this before. We know that we have to pause after played, so we have to group together after the musician played. But on your initial reading, you're going to be tricked. And the garden path model would say that makes sense because you read after the musician played, and then you see the piano, and the rules of syntax suggest that the most likely thing to do is just tack those two words onto that initial clause, and so you do that. And then you hit was wheeled off the stage, you realize you've been led down the garden path, and you have to reevaluate. And so you go back and you reparse the sentence. After the musician played, comma, the piano was wheeled off the stage. We can contrast garden path models of parsing. Again, the garden path model is basically saying that you're just using the rules of syntax. If you encounter a garden path sentence, you will always be led down the garden path. You will always have to reevaluate. We can contrast garden path models with what are called constraint-based models. And constraint-based models suggest that information in addition to syntax, so this is top-down information, can be used to help the parser constrain how we group words together when we're reading a sentence. So if you take, the sentence, the horse raced past the barn fell, it's a lot easier to understand if you embed it in some context, if you give it some greater context, right? So if you read this, these few sentences here, there were two jockeys who decided to race their horses. One raced his horse along the path that went past the garden. The other raced his horse that went past the barn. The horse raced past the barn, fell. So in that context, this garden path sentence makes a bit more sense, and you're a bit less likely, maybe, to be led down the garden path. So constraint-based models would say that you're applying top-down knowledge very early on to help you parse sentences so that you are not led down the garden path. Further evidence for constraint-based models comes from sentences where word meaning can impact how the sentence is parsed. Okay, so the defendant examined by the lawyer was unclear. That's a very ambiguous sentence. Why is it ambiguous? Because defendants can both examine and be examined. On the other hand, the evidence examined by the lawyer was unclear. That's not ambiguous at all, right? Because evidence can only be examined. And so the idea here is that you're using word meaning to help you group words together, to help you parse or understand sentences. And this idea is valid under constraint-based models. It's not valid under garden path models. So garden path models would say that, yeah, you can use word meaning, but only after you've already been led down the garden path. Constraint-based models would say that actually meaning can help you avoid having to reevaluate, having to reparse the sentence that you're reading. So again, the debate here, just like when we talked about, how we recognize words with multiple meanings, the debate here really centers on how early does top-down knowledge impact our understanding of language? Is parsing quite automatic, or can top-down knowledge come to play very early on? Now, in the case of homophones, in the case of understanding words with multiple meanings, we saw that both meanings were initially accessed, and then top-down knowledge came into play. With parsing, it's a bit more unclear. It seems like top-down knowledge, prior knowledge, may be able to help us constrain our interpretation of garden path sentences so that we're not led astray. Here's a final example, some final evidence that prior knowledge can constrain our interpretation of sentences that would otherwise lead us down the garden path. So here's a sentence. Put the apple on the towel in the box. And they were showing participants these images here and tracking eye movements. Okay, so you start at the fixation cross, you hear put the apple, and you move your eyes to the apple. And then you hear on the towel. And so you've grouped together put the apple on the towel, and so your eyes drift over to this towel that has nothing on it. And then you hear in the box, and you realize that you've been led down the garden path. All right? And so you reevaluate, and so your eye movements come back to the box, and you realize, oh, okay, the apple that's on this towel has to go in this box. Now, if we add some additional context, if we add a second apple that's on a napkin, we find that participants aren't led down the garden path. So they hear, put the apple on the towel, and because there's some additional context here, there's another apple that's on a napkin, you realize that, we're not referring to putting the apple onto the towel there's nothing on it. We're referring to the apple that's actually on the towel. And so if we look at eye movements, we see that participants don't move their eyes to this empty towel at all. And so the eye movements simply track the sentence, in a very nice way. So put the apple, it's unclear what apple are we referring to. So participants initially saccade down to this apple, and then you hear on the towel, and oh, the one on the towel, and then in the box, and then they look at the box. So there's some evidence here that, again, context can help us parse sentences with ambiguities a bit more smoothly. And so we're less likely to be led down the garden path, less likely to be tricked. So we've come to the lecture review. What is the lexicon? Question 1. What is the lexicon? The lexicon is our mental dictionary that contains everything we know about words. Question 2. What do lexical decision tasks measure? Question 2. What do lexical decision tasks measure? Lexical decision tasks measure the time it takes for us to identify a string of letters as a word or not a word. For example, glurp is not a word. Question 3. What are garden path sentences? Question 3. What are garden path sentences? Garden path sentences are sentences that require a reevaluation during parsing. So you're reading the sentence, you're grouping the words together in a way that you think makes sense, and then you hit a point where you realize that your grouping is not correct, and you have to go back and reevaluate the sentence. And psycholinguists use garden path sentences because they give us insight as to whether we can use top-down knowledge to help us parse, or whether we simply parse sentences, understand sentences based on the rules of syntax alone.